Hello YouTube. In this video, I'll be showing you how to solve the largest sum contiguous subarray problem. So in this problem, you will be given with an array or a Python list where you have to find the largest possible sum of the subarray within this array. That is, you have to find the contiguous elements in the array which will give you the largest possible sum. So we will be solving this problem using Kadane's algorithm as given here, Kadane's algorithm. So let me go to the code and explain how this works. So in this question we will actually be printing the start and end index of the subarray as well. So let us now ignore how we are finding the start and end index and instead focus on the algorithm. Okay. So in this algorithm, we'll have a main driver code which consists of the array, then the function which implements Kadane's algorithm. So this function will have two arguments, the array and the length of the array. So in this function, we will have two variables, the current max variable and the max sum variable, which will help in evaluating the maximum possible sum. So the way we do this problem is, say we have this array here. So we start by initializing the current max variable that I showed you above. It is already initialized to 0 while the maximum sum is initialized to the minimum value of the array. So in each iteration, so we will be using a for loop to iterate through each element of the array. So in each iteration we have to add the ith element of the array we are taking into account to the current max variable. Okay. So say when we iterate to the first element of this array, so current max will be minus 2. So the logic here is that in each step, after you add the ith element to the current max, you have to check whether this current max value is greater than the max sum variable. The max sum will actually return the final answer of the maximum sum. So what we do here basically is, say in each step we add the element to the current max variable and we check whether this variable exceeds the max num variable. So if it exceeds, we initialize max num to that. So that is how we proceed through each element in this array. Now the other thing to check is, say when we are adding the ith element to current max variable in each step, say if the number is negative, then actually there is no point adding this number. The reason being, say this is the array, say this is your array. Okay, so now we know, say if this array has only positive elements like here 1 2 3 4, then we know that if in each step we add the ith element with the current max variable. Say your current max variable was 0 and in the first element for 1 you added 1 to it, in the next step you add 2 to it, in the next step you add 3 to it, like this you go on. So as you can observe, since all these are positive numbers, in each step when you are adding the number, the current max variable is actually increasing in its value. This is one case. Another case is if all the numbers are negative. If all are negative, then you see that if you add the ith element in each step to the current max variable, the value of the current max variable actually decreases. Say in the first step, current max is initialized to -1. Then in the second step, if you add -2 to it, current max becomes -3, which is lesser than -1. So if you carry on in this way, the current max variable value will actually decrease. So in such a case, what we do is we do not take the negative number into consideration here. And in the third case, which will explain the second case even better, is when you have both positive and negative numbers. So in this case, what happens is, say current max in the first step is initialized to 1. So here in the next step, if you add -2 to it, it becomes -1. Now the logic here is, if you keep current max as -1, in the next step if you have 3 here and if you add 3 to it, then the value of the current max variable will anyway be lesser than 3. Reason being, see 3 is a positive number, so if you are adding it to a variable which is less than 0, the value will obviously be less than 3, right? So it again defeats the purpose of finding the maximum possible sum here. So Instead, what we do is, if at any iteration the value of the current max variable is less than 0, then we equate it to 0. When we are equating it to 0, what we are doing is we are basically ignoring the previous elements that we added. So in this case, we added 1 and minus 2 to the current max variable and we got minus 1. So when we got minus 1, we equated current max variable to 0. When we are doing that, we are basically ignoring the sum of the first two numbers, that is minus 1 and minus 2. So instead, in the next iteration, when we have 3, we add 3 to current max, which is initialized as 0. So why we are doing like this is because, say, in this array, we know that the maximum possible sum is 3. The reason being, if you keep on including the negative numbers, the sum will actually decrease. So in that way, we are compensating for it by equating it to 0. So that is what we're doing here. So the algorithm is designed in this way. So what we do is, say, like I told you, in every iteration we are adding the ith element to the current max. After that, we're checking if current max is greater than the maximum sum. If it is greater, we initialize it to current max, the maximum variable, so that we can print the maximum number. And this is the second case which I explained a few seconds back, that if current max is less than 0, then we equate it to 0, so that we do not consider the negative numbers because they anyway reduce the sum. So now that we are clear with the algorithm, let us go with taking a look into how we are finding the start and end index of the subarray. So for that, we need three variables, start, end and s, which we initialize to 0 here. It is obvious that start will give the start index and end will give the end index, and s is basically a reference variable. So what we are doing is, the moment we find that current max is greater than max sum, that is the moment we know that we have found a subarray whose sum is greater than the previous considered sum, which was stored in max sum. So in such a case, we know that there is a possibility that this current subarray sum can actually be the greatest sum of the array that we are taking into account. So in such a case, what we do is, the last element that we check for in the loop will obviously be your end index, and the start index we initialize it to s. The reason being, since s is also initialized to 0, so in this way s is basically keeping track of the start index. Okay, and here we see that the times when the sum of the ith elements gives a sum which is less than 0, we equate it to we equate the current max variable to 0 in such a case, so as to ignore those negative numbers in while considering the sum. So that is the reason why in such a case, the ith element till which we are ignoring, we are incrementing s to one value after that in the array. Like in this case, for example, like in this case here. So when we encounter minus 2 here, we will actually increment s to the index of the value 3 here, so that we do not consider the first two variables, that is 1 and minus 2. So that is the reason why we are using s equal to I plus 1 here, so that when we again start following the algorithm, in the scenario we find the maximum sum, start variable can have the appropriate start index value, which is governed by s out here. So this is the logic behind Kadane's algorithm to find the largest contiguous subarray in the given array. So if we run this, we will see that the largest possible sum is 7 and the start index is 2, that is from 4, till end index is 6, that is till here. So 2, 3, 4, 5, 6, sorry, till here. So this is the subarray from 4 till 5, which will give you the largest sum. So that is how this problem is solved.